is a three dots. Okay, just click on that dot and you can change your screen like full screen. Okay, adjust your screen. Am I audible to you?
Yes, ma'am.
Yes. Today we are having very less time, so directly we are going to start our main demonstration. Is my screen is visible?
Yes, yes, sir.
Yes. Okay. Today we are going to show you the automation and process control lab. This lab is designed for NSQF level 7 that you are conducting. Okay. This is your NSQF level 7 curriculum. Okay, sir. Like unit 1, unit 2, unit 3. We have designed labs such as you can conduct all the experiment which are mentioned in your NSQF. Okay, this is the proposal that I gave you. In this complete lab, first we are going to see how your unit is conducting. Means for your unit number 1, 2, 3, 4 and 5, we are having the Automation Studio software. Okay, for unit 4, we are having input output interface box. Unit 5 and 7, we are having industrial PLC trainer kit. And for unit number 3, we are having industry grade mechatronics sensor trainer. Unit number 2, electrical machine trainer. Unit number 9, process control trainer for pressure, temperature, flow. Okay, now this session we are going to start with this process control trainer. Okay, and the DCS ProSimulator software. For this webinar, we are going to start with ProSimulator 1, means PS 1000, 2000. How you are going to conduct your unit number 9, we are going to see in the demonstration. Okay, I request Raman sir to please show you the PS 1000 and 2000. Then after the PS 1000, 2000, we will see the pressure, temperature, flow trainer. Means how you are going to do the your all the practicals on the software, then on the hardware. Okay, Raman sir, am I audible to you?
Yes, you're audible.
Yes, yes. Please present your screen, sir.
Yeah, okay.
Yes, present now. There is an option down. Present now.
Doing that.
Yeah.
You are able to see my screen?
Yes, sir.
Yes, sir.
Yeah, good evening to all of you. This is a presentation on the simulation software. Basically, this software, this simulation software is intended to replicate an actual industrial equipment or a plant or a section of the plant. So this has various modules. We have two packages primarily. One is PS 1000 and PS 2000. I will take one example from each of them and briefly demonstrate how this can be useful to your training. So I'll first log in, and once I log in, I can select the package. First, I'll select the PS 1000 package. So we have got various modules in PS 1000 package. I will select, let's say, one example, pressure controller to illustrate. So once I select the particular module, then the trainee will be able to see the display in the following manner. Actually, in the industrial, if you go to industry, you got various equipments, and these equipments are connected by pipeline, and some feed is put and product is taken out. Now, in most of the complex, what we are doing is we have a control room, and all the measurements are done. Various measurements like temperature, pressures, levels, flows across the plant or the equipment are measured, and these measured values are transmitted to the control room, where in the control room on the computer you will be able to see pictorially, graphically, you'll be able to see the equipment and all the parameters related to the particular equipment. So this is very, very convenient method to monitor and operate the plant. So we call this as a distributed control system, where It's a centralized control room computer on which the sections, each sections of the plant are displayed for the trainee or the operator, and you can monitor the plant from the control room, as well as you can operate the plant from the control room. Now, this is an example of a pressure controller to teach the student how a pressure controller functions. So I have a vessel, and this vessel has got two feeds, two gas feeds. One is coming from some section. It has got a flow rate of, both have flow rate of 1000 kg per hour. Second feed also has 1000 kg per hour. And these two feeds are fed to this vessel. And from there, a product is taken out. This product is a total of feed A and feed B. The total is 2000 kg per hour. Now, one thing is, your objective is to control the pressure of this vessel. So there is a controller here, pressure controller, which basically measures the pressures in the vessel, and the measured pressure is sent to a controller where the control valve will open or close according to the requirement of the pressure. So now the pressure is 3 kg. Based on the feed that you are putting and the product you are taking, it is steady. The pressure is steady at 3 kg. Now, if I want to change the pressure, increase or decrease the pressure, this is a programmable loop controller. It's a microprocessor where I have the measured value. Measured value is 3 kg, which is displayed here. And this is the desired value. Desired value is also 3 kg. And the third element is showing 40. 40 is the valve position. Now, valve is open 40%. Suppose I want to change the desired value for, say, 2.8. I can just go and change to 2.8. What will happen is, if you see here, it will calculate. There is an error between actual value and desired value. Because of the error, the output will be calculated based on proportional integral derivative calculation, PID calculation, and the valve will get closed or opened according to the requirement. Now, here you want to reduce the pressure. So what will happen? It will basically increase the valve so that more gas is sent out and pressure is coming down. So if you see here, from 3 kg, pressure is gradually coming down to 2.8. So because the valve is so, and the flow rate also, if you see here, the flow rate has increased proportionately. Because valve is open, flow rate is increased. Section and discharge pressure also will get, these two flows also will get affected slightly because my vessel pressure is changing. Because this flow is calculated based on the delta P. The section supply pressure is constant. The drum pressure is changing. Because drum pressure is changing, this flow also is changing. This flow also is changing. And output flow is also changing because I have changed the valve position. So the trainee can change the desired value as he likes. He can make it 2 kg or 1 kg, whatever way he wants it. He can change, big change or small change he can make. Accordingly, the controller will work. And the flow rates will get changed. And slowly the process will get stabilized. Now it is on transient. Everything is changing because as a function of time, the parameters are calculated in the simulation model, and it is like a real plant, the values are changing. This is what you will see in the control room also. Now, if I want to see how the process is changing with respect to time, I can go to another display we call trend display. Here I have time as x-axis, and y-axis has got all the parameters. So the first parameter shows the pressure of the vessel in red color. Then second tag shows the flow of the flow, feed rate 1, feed rate 2. And so each parameter are displayed in different color. So you can compare how they are related to each other. If I change the pressure, how other flows, other parameters are dynamically changing, which I can, therefore I can study the dynamics of the process using this trend panel. This is the facility available in the DCS. I can zoom this trend also. If I want to enlarge, I can enlarge scale, I can see. I can keep on zooming, or I can also reduce the scale. Or I can go back in time also. Suppose now it is now, I started trending at this time. Suppose after some time you will see it is crossing. Then I can also move the cursor and I can keep shifting the cursor. I can go back in time and see what has happened at that time. So this is one facility. This is a normal facility, which is graphics. And then we have got, this is called faceplate. Any particular parameter I can click and I can see the parameter in more detail. So if I say go to the pressure controller, now I can go and see more detail of this particular controller. This is called detail page or tuning panel, where the parameters are more internal parameters of the particular controller are shown. Like this is the current value, this is a scale range, then what is the alarm range, and then what is the PID values, proportional integral derivative value. So you can even change the PID value and change the behavior of the controller. Suppose you find the controller is very slow, you can increase the speed by changing the PID values, or if it is too fast, I can reduce. So based on your PID setting, the controller action will also work. The student can learn how to tune this PID controller. If I want to make it very fast, I can change the controller tuning also. Hello. So that is feasible in this particular tuning panel. Now in the tuning panel, it will trend only the parameters related to particular tag, the process value and set value. Rest of them will not be displayed. So basically, I can just say suddenly stop this feed, and then I can see what is happening. If you see here, I'm getting an alarm and it is blinking. I can go to the alarm page, which will at this particular 9th January at this 5:28 p.m. This particular controller has become low. So this is an alarm panel which captures the attention of the trainee, and that is a facility available in the DCS. So you can operate this plant and do whatever you like. And suppose I want to shut down this plant, I can just close this flow also. See, there are two different type of valves. This valve is on off. That means either I can close or open. But whereas this valve, I can vary 0 to 100 anything. I can just say 10%, 20%. I can change the valve opening as I like. Accordingly, the flow rate will be regulated. So this is like a gate valve and this is like a globe valve. So these are all different type of valves available in the industry. And this is a control valve. So because I reduce the flow rate very drastically, 0 and then 244, the output also will accordingly change. My controller is taking action, and to maintain the pressure at 2 kg, it will adjust the output such a way that the pressure is maintained and the flow rate is also adjusted. So I can increase the pressure. If I want to increase the pressure, I can again increase the pressure. I can play with that as I like and learn the configuration of this plant, the dynamics of this particular process, and also the instrumentation and control system which are available in this particular process through the DCS control. So all the facilities like trend, alarms are available in this particular simulator, just like a real plant. And there is another facility also called a group page, where you can also see the process in different format. Like this is a controller, pressure controller. This is a flow controller. This is the second flow. So I can also see it in differently. So these are different way of looking at the plant, but same plant. So now I have tripped the whole flow, and then the pressure has gone very, the output flow has reduced. And since I want 3 kg, it is reduced. It is close the valve and trying to get the 3 kg pressure. So basically, this is an example of a simple example of how simulation can be used to teach the process of pressure control, which is adopted in the industry. So from the instructor, you can also give malfunctions and train the student by giving various malfunction. This is a very simple example, so there is no big malfunction, but I can change even the supply pressure. Suppose supply pressure, I want to change it to 4 kg. I can change the supply pressure to 4 kg if I require. So I can modify the parameters of the battery limit as well as the controlled parameters. So like this, I got different exercises to teach the student on various process control concepts, like starting from on-off control to PI, flow controller, pressure control, level control, cascade control, split range control. So various type of controls can be taught to the student. They can try themselves, play with that, and learn that thoroughly. Then we have another module which is little more detailed. These are all for much bigger industrial process. So again, I'll take one example. Let's say I take a distillation column, which is a standard equipment available in a industry, process type of industries. So once I load the simulation software, the software is now running. I can invoke the trainee station, and I can see the graphic representation of the plant. So this is a distillation column, where the purpose of the distillation column is you are putting some feed. The feed is a hydrocarbon feed, and this hydrocarbon feed is sent to the distillation column. This distillation column has got various trays, series of trays, and here I will supply heat from the bottom, and vaporize the light component present in the feed, and remove the light component in the top, and whatever is not removed will come as a bottom product. Basically, the objective of the distillation column is to separate light and heavy product which is present in the feed. So that is the objective of the distillation column. But the distillation column is more complex. We have got a lot of instrumentation here. So here, for example, I have got the analyzer which shows the quality of the feed rate. Then there is a flow controller which regulates the flow to the distillation column. Now it is 190 cubic meter per hour. I can change the flow rate as I like. If I want to make it 100, I can just set the set point as 100. Automatically, the system, the control valve will be closed. The controller will close the control valve to make the flow to 100. See, gradually the flow is coming to 100 and it will stabilize at 100. Because I reduce the flow rate, other parameters also will be accordingly affected. Now, then here there's a top pressure controller which regulates the pressure in the distillation column. Then this is a vessel where this vapor which is going up is cooled and it is condensed and collected in this vessel, and I'm removing the top product. So in the top product, I got a flow rate of the top product and also the quality of the top product as 97% purity. So I can make any change into any of these parameters. Like this is the bottom heat I'm providing through supplying steam. I can change the bottom temperature. Now it is 103 degrees centigrade. If I want to change the temperature, I can change the temperature and see how my other parameters are changing in the distillation column. So in the distillation column also, I can have a trend as a function of time, various parameters. Because I change the flow rate, which is red color, how other parameters are changing dynamically, I can study and understand the dynamics of the distillation column. Now, I made a change because I changed the flow rate, all the parameters are changing. If I want to bring back the normal condition, I have a facility here. I can just go and reset it. Once I reset it, I'll be able to see everything steady now again. It is like a reset situation to design condition. Now everything is constant. Now I can make another change. For example, if I want to change the bottom temperature, I can just say instead of 103, let's say I want to write 95 degrees centigrade. Then what will happen? It will cut down the steam flow. If you see here, steam flow is 26. Now it is cutting down the steam flow in order to reduce the temperature in the distillation column. By reducing the supply of steam, heat supply will reduce. Heat supply reduce means temperature will come down. But it will be a slow process because the temperature change is always slow. Slowly, because there is a lot of hold up in this distillation column, slowly the temperature will start coming down. Because temperature is coming down, all the parameters in the distillation column will change. My separation between the light product and bottom product will be changed now. My quality also will change. In the top product, quality also will change. Top product feed also will change. So by changing any parameter, you can study the behavior of a distillation column. Now, the advantage here is if you have a lab equipment of a distillation column, you have to do carefully, because if you do as you like, you will damage the equipment, and also more than one person cannot change at a time. But whereas here in the simulation, the advantage is it's a software. So in your lab, all computers can have the same software. Independently, the student can make the understanding. They can run the simulation model and do whatever they like independently. So one person can.
Sir, please show them the list of the model which are available in ProSimulator 1000 and 2000 set.
Yes, I will open up the screen. So what is available in the 1000 model are on-off control of level control, temperature control, flow control, PI and P control, pressure control, level control, cascade direct and cascade control, split range, and then ratio control, feed forward control, 3-element boiler control, and control valve characteristics. So all the topics which are typically taught to diploma holders and engineers in process control and instrumentation are covered in this process control PS 1000 package. And similarly, in PS 2000, this covers all the equipment like distillation column, boiler equipment, pump operations, flash tank, heat exchangers, furnace, CSTR reactor, then fixed bed reactor, plug flow reactor, evaporator, crystallizers, and then centrifugal compressors, gas turbine, cyclone separators. So various type of equipment, which are complex equipment, which are deployed in process industry and power plant, are all available. And you can choose any simulation model at any time, and you can demonstrate in the classroom as well as students can independently try out.
So we have last 5 minutes. In
Yes.
that, show them DCS emulation platform.
Yeah, I will show that. So this is the emulation which I was talking about. This emulation has got a lot of facility. One facility is called graphics window or schematic view. And this is a view you are seeing now. From here, I can click and I will get the faceplate of a particular parameter, and I can make changes in the faceplate. Then second facility available is we call the any particular tag. You can click and go to the detail page, and this detail page will show all the internal parameters of a particular parameter. And you can also do tuning. You can change the PID settings and tune the parameter, and make sure that the controller works very well and stable. Then another facility available is a trend page, where the trend of various parameters as a function of time is shown to you. The third other facility available, or you got an alarm panel, where various parameters, whenever there is an alarm coming, because I made changes, it will have a timestamp event, alarm sequential event which are
So
happening.
DCS simulations from Honeywell and Yokogawa, those models.
Yeah, I will show. This is what representation of Yokogawa. Similarly, you can also have other DCS, like for example, I can show also Honeywell. Honeywell has slightly different method of displaying. So Honeywell, the graphics page will look similar, but if I click the faceplate look will be different for Honeywell. Yokogawa, what I showed earlier, slightly different from Honeywell. But similarly, if I go to trend page, Honeywell trend will look slightly different. The functionality is same, but the HMI look will be different for different DCS. So similarly, if I go and then click the detail page, the detail page for Honeywell has a different display. Though the information is same, but the way in which they display is different. So you can have the view of the plant, whichever DCS you want to select, you can select, and you can the trainee can get the feel of the system. Similarly, if you go to alarm page, the Honeywell alarm page looks different. So model is same, but you can have view differently based on the automation vendor HMI. That is the facility available in the DCS. So
Okay, so that is what now they're calling that they have some time limitation. So we'll wrap up our session here, sir.
yeah, you have a lot of malfunctions available. One can train the students on all malfunctions, and for different processes like power failure, instrumentation failure, steam failure. So a lot of facilities are available in the simulator, which will be possible to very usefully for the training programs.
Okay, Begum ma'am, if you have any question, then you please ask. Otherwise, we'll wrap up the session. Sumi ma'am. Okay. I don't think they have any question. So
Okay.
we will wrap up the session, sir. Okay.
Okay. Thanks a
Yes.
lot.
Thank you very much. Thank you very much for it.
Thank you so much, sir. Thank you.
Yeah.
हाँ सर बोलिए
Ma'am, do you have any question? Okay, ma'am. So we'll wrap up the session today. Okay. Thank you.
Thank you very much. Bye.
सर हम लोग मंडे डिस्कस करेंगे